I welcome you all to learn on the topic of how to select the suitable sizing for PV and battery for home appliances. Now you can consider. So here I am going to show the example. The example will demonstrate how to choose the PV panel and also how to choose the battery for our home appliances. For example, we are using an inverter in our home. So how to select the battery sizing in our home, and accordingly if you are going for upgrading the PV panel in our home, what is the size of the panel we have to choose. So here we are going to consider the certain parameters to perform the certain calculations in the things. You can see here we have considered the three kinds of load. The load one is 18-volt fluorescent lamp with electronic ballast using 4 days per day, 4 hours per day. So 18 watts bulb we are using 4 hours per day. Similarly, you can see the second load is 60-watt fan using 2 hours per day. So it means that 60 into 2. The third load is 75-watt refrigerator that runs 24 hours per day with compressor run 12 hours on and 12 hours off. It means that the 75-watt refrigerator is going to be working for 12 hours per day because it is a on and off cycle is there. So on cycle is 12 hours, off cycle is 12 hours. So we are going to consider these parameter as um 75 watts per to 12. So here you can see again the PV panel we are going to consider for the design is 12-volt DC and 110 watt hour, uh, 110 wattage panel we are considering for the PV module. So first, what is the first step one? The step one deals with the determining the power consumption demands. So the step one, determining the power consumption demands. So you can see the total appliances we have using the three different loads. The load one is 18 wattage into 4 hours, and the load 2 is 60 wattage into 2 hours. So this is a light, and this is a fan, and this is a refrigerator. Refrigerator you can see 75 watt into 24 into zero point 0.5 hours. It means that the total conversion will leads to 12 hours. 24 into zero point 0.5 means, so the if the refrigerator is continuously operating for 1 hour, the zero point 0.5 hours will be working, the zero point 0.5 hours will be the off cycle. So on cycle and off cycle accordingly classified. So that's why we are considering 75 wattage into 24 into zero point 0.5. It means that 24 into zero point 0.5 means it is 12 hours. So the total wattage required for the day is 1092 watt hour per day. So the total PV panel we required here is 1092 into 1.3. So this is the parameter we are going to use how to calculate in the system. So the total wattage you can see 1092 into 1.3. What is the meaning of 1.3? Here the meaning of 1.3. 1.3 means there is a energy losses will happen in the system. So that's why what we are doing, we are multiplying with a constant multiplication factor 1.3. It indicates the energy lost in the system. Because we know that the solar panel, if I am placing the solar panel for in the real time application, it can able to generate the efficiency of 18 to 24 percentage in the real time. If I am placing 100 wattage panel, you may get a 24 wattage in per the day. So we have to consider the energy loss in the system also. So accordingly, the total PV panel energy needed is here 1092 into 1.23. That is of 1419.6 watt hour per day. So based on this, we are going to be consider the total PV energy needed in this particular panel. So now considering to the next parameter. So this is the step one. Step two, we have to determine the size of the panel. So the size of the panel we know we already calculated. what is the total watt power required for using the panel? 1419. It is the total wattage we need to supply for the particular three loads. So here I have to divide those values with 4.32. It means that it is called as a panel generation factor. So in every country, the panel generation factor is going to be getting varies. So if I'm considering India, the panel generation pointer factor will be 4.32. If I consider Thailand, it may be a 3.4. If I consider China, so the panel generation factor is already determined for all the solar panels. So depend upon the country, the generation factor is going to be changed. So what is the panel volt watt we require? We have to divide those panel volt by the panel generation factor. So now you are getting the watt power is 95.810. So this is a panel we have to establish in our home. So how many number of panel we need? Already we have decided. Here you can see we have already in the question itself we have given 12 voltage 110 watt panel we are going to consider for this design. So accordingly what happened? We are considering 110 watt. So the value which arrived through the panel generation factor is 95.810. The 95.810 is divided by 110. So approximately we need one module of 12 volt and 1110 wattage panel is required for our home to supply the three loads. The actual requirement is one module. So one module has a power rating of 110 watt power. Next factor we have to consider. Next factor we have to consider inverter sizing. How you have to select the inverter sizing? For example, we know the wattage of the appliances: 18 watt, 16 watt, 75 watt. So this is a tube light watting, and 60 watt is the fan power rating, and refrigerator power rating was 75 watts. The total watt was 153 wattage. So while you are going to considering to select the inverter should be selected according to 25 to 30 percentage of this particular the load. So if we are saying that 25 to 30 percentage of the load, we are going to be considered the inverter size should be able to distribute 190 wattage or greater than. We can consider it greater than 190 wattage also. So normally we are going to be considered only 190 wattage, or else some cases we can go with 1 to 50 wattage. So this is the way we have to size our inverter. So this is the step 3. Step 4, we have to determine the battery sizing. This is an important parameter. How we are going to resize the battery sizing. So normally the battery sizing, we have to select the deep cycle battery for the PV panel appliances. So most of the cases we are using the deep cycle battery. What is the meaning for the deep cycle battery? Means when the battery is designed to discharge to the low energy level, at the same time it is rapidly recharged. Deep cycle battery means it is going to discharge up to the lower level of the energy level of the battery, and apart from this, the battery can be recharged immediately and discharged after days for a long period of years. So that is the difference between the normal battery and deep cycle battery. If you are going to purchase the battery now, the battery has certain rating. Deep cycle battery or normal battery, that kind of classification has been mentioned in the manual. So almost nowadays the tubular batteries are coming with the deep cycle batteries. So the batteries can be able to discharge to the lower level. At the same time, it can be rapidly charged within a particular hours. So here, while going to consider for the battery for the PV panel, what are the things I have to consider? One is the total watt hour per day we are using in the appliances, and the next, what is the total watt hour per day has to be divided by the 0.85. It is the standard rating to calculate the battery. And again, what is the value we are arriving over here? Again, we have to divide it by 4.6. The 0.6 represents the depth of discharge. So normally we can say the state of charge, state of discharge. State of charge means that it is used to charge the battery. State of discharge means the battery used to discharge the value to the load. So what is the maximum depth of discharge can be happen? It is a 0.6. So we have to divide the 4.2. What is the value arrived in the second section? We have to divide with the 4.3. Again, the value, the total values will be divided by the nominal battery voltage. So the formula is arriving over here. The battery capacity AH is equal to total watt hours per day used by the appliances divided by 0.85. It is a battery loss, considering a battery loss, and zero point 0.6 is the depth of discharge and the voltage of the battery. Either the voltage will be the 12 volt or 24 volt. It is a what is the voltage we are considering, that we have to consider over here. And next is the days of autonomy. So what is the days of autonomy? Days of autonomy means the battery is capable to deliver the power to the particular load without having the recharging cycle. For example, there is a no supply is available for the next 2 days. So we have to consider those parameters. For example, the 2 days the supply is not available. The battery has capable to deliver the power to the particular appliances for the next 2 days. That is called as a days of autonomy. So you can consider without 3 days, if the 3 days are the power is not available, the battery is capable to supply those power to the particular appliances. So this is a way we have to select the battery. This is a detailed procedure to select the battery in the appliance, battery in the applications. Now we are going to see the real-time calculation. So almost we have determined the total appliances. We know the total appliances. One is the light. Light we are going to use for 4 hours, and fan we are going to use for 2 hours, and refrigerator it is going to use for 12 hours. So this is the total appliances usage, and the nominal battery voltage we are considering is a 12 volt. And days of autonomy means 3 days. 3 days means without supply, battery able to supply the load for next 3 days. That is called as a days of autonomy. So here again you can see the battery rate capacity is equal to, we are placing the numerator as a total appliance usage into 3. The 3 is the days of autonomy. Here the energy loss, depth of charge into 12. The total ampere hour will be, we have calculated, is 535.29 ampere Ah. So the battery rating we are going to be select 12 volt 600 Ah. We have determined 535. So we have to choose the value above the 535. So here the next to the 535 is the round figure. We can say 600 Ah battery is available. The 600 Ah battery is able to supply the particular load without having any supply for the next 3 days. So this is the way we have to size our battery for the real-time appliances, and also we have to select the battery for the PV appliances also. And next one is a solar charge controller sizing. Solar charge controller sizing means we have to use the solar charge controller to charge the batteries. We are not able to connect the battery. For example, here the panel is available. We can say this is the panel. The panel voltage is not directly connected to the battery. Here if I am connecting the PV panel directly to the battery, means there is a fluctuation of voltage will happen due to the solar irradiations. So here we have to establish the solar charge controller between the PV panel and battery, because the solar charge controller enables constant volt constant power, that it means that constant current and voltage, constant current will be able to enable the charging of the battery. So the charge controller used to maintain or provide the constant supply to the battery to for the charging purpose. So whenever we are using a PV panel, we have to place the charge controller next to the PV panel. The charge controller is connected to the battery. So this is the basic things. So here, how we are going to calculate the solar charge controller sizing. You can see the power of the solar panel is 110 watt power, and the voltage of the panel is 16.7 VDC, and the maximum current is the 6.6 ampere. And we can consider whenever we are going to choose the solar panel now, these two ratings are defaultly available in all the solar panel. One is the open circuit voltage, another one is a short circuit current. Short circuit current. So here, how we are going to select the solar charge controller rating. So the basic formula is equal to total short circuit current of a PV array into 1.3. So this is a standard practice we are using in India. The total short circuit current of PV array into 1.3. So how many strings we need? Strings means how many panels we are using. The panel we are using is 1, because already we have determined those panel rating in the step 2. You can see once again. So here you can see the step 2, the size of the panel. So the size of the panel we are using is one module. That is, one module means it is simply, we can say that it is called as, one module is called as a string. So the one string is into 7.5 amps, because the short circuit of current rating of the panel is 7.5 amps into 1.3. That is the multiplication factor we are defaultly used as a standard practice. So the total rating of the charge controller is 9.75 amps. So we have to choose the round rating next to the 9.79 rating. So the solar charge controller rating will be the 10 amps at 12 volt voltage or higher also. We can go for 10 amps or 20 amps, but we need a minimum of 9.7 amps solar charge controller to charge the batteries. So this is a way we have to resize our this is a way we have to design or design the solar PV system with batteries. Once again, I am going to revise the topic. What are the detailed procedure to design the solar PV system design? First one, you have to determine power consumption demands. So what is the load you are going to use? What are the loads you are going to connect to the PV panel or the battery? So total power consumption demands. Next, based on the power consumption, we have to go for size of PV panel. So while selecting the size of PV panel, we have to use the panel generation factor. Panel generation factor. And again, 3, we can see inverter sizing. The inverter sizing means, so based upon the load, what are the loads we are using? We have to decide the loads above 25 to 30 percentage of the actual load rating. If the load rating is 150 watt, we have to consider 190 watt inverter for the next appliances. The fourth point is we have to decide the battery sizing. So battery sizing means how we have to select the battery sizing. There is a simple formula we are using. That is the total watt hour per day used by appliances divided by 0.85, that is a 0.85 is a battery loss, into zero point 0.6, that is the depth of discharge, into 12 volt, that is the voltage of the battery, into days of autonomy. So the battery is capable to supply the appliances without charging for the next 3 days. So how many days you are selecting, accordingly you have to select the battery sizing. The last point is we have to select the solar charge controller. So solar charge controller means the controller used to charge the batteries. So how we are going to decide the rating of those batteries? So the basic formula for the solar charge controller is total short circuit current for PV array into 1.3. There is the multiplication factor of 1.3. So what is the panel rating we are considering? Accordingly, we have to multiply those values. We are going to get the current rating of the solar charge controller. We have to choose above the particular rating arrived in the step 5. So this is a way we have to use the practical sizing of the PV panel and batteries in the appliances. Thank you.